Hi students, welcome to Methodology classes. In this lecture, we are going to discuss MCQs based on the triangles which can be asked in the CBSE Board 2026. You will get one question from this topic in the MCQ section, and this is the simplest polygon about which we started studying in the geometry section. So let's start. So the first question is, triangles ABC and DEF. In triangles ABC and DEF, angle B is equal to angle E, angle F is equal to angle C, and AB is equal to 3DE, 3 times DE, then the two triangles are. So there are four options. We have to select one out of that which is correct. So now what is given about the two triangles? That angle B of the first triangle is equal to angle E, and angle F of the second triangle is equal to angle C of the first triangle. So we know that two angles of the first triangle are equal to two angles of the second triangle. And we know for similarity we need two triangles of one triangle equal to be two angles of the other triangle. So we can surely say that the two triangles are going to be similar to each other. They can be congruent if they have the same size also, means all the three sides are equal. But here it is given that AB is 3 times of DE. It means they are not congruent, they are not of the same size. They have the same shape because they are similar, but they don't have the same size because AB is 3 times of DE. So we can say that the triangles will be similar, but they will not be congruent. Now let's see the other options also, why they are wrong. So first option is congruent but not similar. But we know that every congruent figure has to be similar. Every congruent figure has to be similar. So this cannot be our answer. Congruent as well as similar. So congruent means same size, but here they are saying that AB is 3 times of DE. So they surely don't have the same size. So option B will not be the answer. Neither congruent nor similar. So but it is given that two angles of the first triangle are equal to two angles of the second triangle. It means they are similar. So this also cannot be the answer because it is saying nor similar also. So I hope this would have been clear. So this was an easy question just based on the definition of the similarity. So if you are aware about the concept of the similarity and congruent without knowing any formula, you can solve this question. Second question is, which of the following statements is incorrect? Which of the following statements is incorrect? So in such questions we have to be very alert because it is asking which is incorrect. Generally in our mind we think that which one is correct and we take and move to the next question. But we have to train our mind that read the question carefully, even if it takes a little bit more time, because if we understand the question then we can easily answer it. And even if we don't understand it, so we will mark wrong answer and move to the next question. So it is asking which of the following statements is incorrect. So let's check the first option. Two congruent figures are always similar. So this is as discussed in the first question. Two congruent figures will always be similar. So this cannot be our answer because it is asking which is incorrect. So this is not our answer. Let me choose a different color. Okay, let's talk about the option B. It is saying a square and a rhombus of the same area are always similar. So if we know that two figures are said to be similar if their sides are proportionate and their angles are also equal. But in rhombus and square, it's not necessary that angles will be equal. So this is incorrect. This will not always be true. So this will be our answer because the question is asking which is incorrect. Now let's see option C and D also. Let's discuss because right now we are learning. We are not in the exam phase. If in exam if we get that option B is incorrect, we will move to the next question. So option C says two equilateral triangles are always similar. So we know equilateral triangles, all the angles are 60 degrees. So in two equilateral triangles, all the angles will be equal. So they will be similar. So this is not incorrect, this is correct. And option D, two similar triangles need not be congruent. So we know in similarity what is necessary? The shape should be same. So two similar triangles will be similar in shape but it's not necessary for them to be of the same size. So it's not necessary for them to be congruent. So this is also correct. So this cannot be our answer. So option B will be our answer, that a square and a rhombus of the same area are always similar. So one thing more we can learn from this question is that even if I don't know that B is correct or not, but I surely know that A, C and D are correct. So A, C and D cannot be our answer. So only option B can be our answer. So that in that way also we can think. So in MCQs, this is a very interesting thing. Even if I don't know the correct answer, but I know that 3 of the options cannot be our answer, so we can figure out that only the option left will be our answer, whether we know that or not. Okay. So moving to the question number 3. It is saying, if in two triangles, triangle DEF and triangle PQR, two of the angles are given, angle D is equal to angle Q and angle R is equal to angle E. So two of the angles of the first triangle D and E are equal to two of the angles Q and R of the second triangle. Then which of the following is not true? So again, it's very important to read the question carefully. It is asking is not true. So don't focus on finding out which one is correct. So angle D, so if I write triangle DEF is similar to, triangle DEF is similar to, so we can see that angle D is equal to angle Q, so it will be Q, and angle E is equal to angle R, so QRP. So this will be the sequence of the similarity. Triangle DEF will be similar to triangle QRP. So now let's check the options. So first one is saying DE by QR. So DE by QR. So DE is the first two letters, QR are also the first two letters of the second, will be equal to DF, so first and third of the first, so QP, first and third of the second, so QP or PQ. So first one is correct, but it is asking which is not true, so this cannot be our answer. Now option B says EF by PR. So EF, second and third, so PR, again second and third of the second triangle, is equal to DF. So first and third will be equal to PQ, first and third. So this is also true, but we have to see which is not true. Now let's check the third option, C. It is saying EF by PR. So second and third EF by PR is equal to DE, first and second, by QR. DE by QR. So EF by PR is equal to DE by QR. So again this is true, so this cannot be our answer. Now let's check the fourth option, D. So it is saying DE by PQ. So DE by PQ, D first and second, but here it is taking the first and third letter. So that cannot be true. If I am taking the first and second of the first triangle, then it will be proportionate to first and second of the second triangle. So this will be our answer, because the question is asking which is not true. So the option 4D is not true. Okay. So I hope this would be clear. So let's go through this question once more. If in two triangles, triangle DEF and triangle PQR, it is given that D is equal to Q and R is equal to E. So we wrote triangle DEF will be similar to, because angle D was equal to angle Q, so I wrote Q first. Angle E was equal to R, so I wrote R, then the third P. So we got that DEF is similar to triangle QRP. Now it is saying which is not true. So first option is DE by QR. So taking the first two letters of both the triangles, so DE by QR will be equal to DF first and third, then QP first and third. So this was true. So this cannot be the answer, because the question was asking which is not true. Now moving to the option B, it was saying EF by PR. So EF by PR, I took the second and third and second and third of the second triangle also will be equal to DF first and third, then first and third QP. So this was also true. Now option C was saying EF by PR. So I took second and third EF, then second and third PR will be equal to DE by QR. So first and second letter of the first triangle, then first and second letter of the second triangle, DE by QR. So this was also true. Now in the option D, it was saying DE by PQ. So it took first and second letter of the first triangle, but it was taking first and third letter of the second triangle. So that will not be in proportionate. So our option will be D, because the question was asking which is not true. So in this way we arrived at our answer D. Now moving to the question number 4. So it is, in this question, two triangles are given, LMN and triangle ABC, and we have to find out the length of the side AC. Remaining information is given in the figure. So if we analyze the figure, there are two obtuse angle triangles LMN and ABC. Two angles are given of the first triangle, 130 and 28. So I can find out easily the third angle. So 130 means sum of these two angles should be 50. So one angle is 28, so other angle will be 22 degree. Now again 130 is given one angle, so sum of the other two angles will be 50. So one is 22, so the other one will be 28 degree. So we got the three angles, and we saw that all the three angles of the one triangle are equal to all the three angles of the other triangle. So we can surely say that they will be similar. The two triangles are similar to each other, and if they are similar to each other, their sides will be proportionate. So now let's see. So we have to find out the length of the side AC. Now which sides are proportionate? Many times students are confused that which sides they will take as proportionate. So one simple rule to find out that is side opposite to equal angles are in proportion. So we have to find out AC. So AC is opposite to angle B, and angle B is equal to angle M. So AC will be proportionate to 72. But in what proportion? That we will get by finding out side opposite to 28 degree in both. So side opposite to 28 degree in triangle ABC is 5, and side opposite to 28 degree in the triangle LMN is 45. So we can see that the sides of the triangle ABC are 1 by 9 times of the sides of the triangle LMN. So in the same way, AC will be 1 by 9 times of LN. So 1 by 9 times of LN, that is 72. So 9 8s are 72. So we can say AC will be 8 centimeter. So our answer will be 8 centimeter. Okay. So let's quickly go through how we solved this question. So first of all, two triangles were given, their angles was given, and all the three sides of the first triangle LMN was given, and one of the side of the other triangle was given. So we first inferred that all the three angles of LMN are equal to all the three angles of ABC. So from there we concluded that triangle LMN is similar to triangle ABC. Now if they are similar, so their sides will be proportionate. So side opposite to 28 degree was known in both. So from there we found out that AB is 1 by 9 times of LM. So from here we know that we came to know that every side of ABC, triangle ABC, is 1 by 9 times of the sides of the triangle LMN. So from there LN was 72 centimeter. So from there we found out that AC will be 1 by 9 times of the 72. So that is 8 centimeter. So I hope you would have understood this question. Moving to question number 5. In the given figure, in triangle ABC, AD is perpendicular to BC and angle BAC is 90 degrees. So this angle is given to be 90 degree. And BC is equal to 16 centimeter, DC is equal to 4 centimeter, then the value of X is. X means we have to find out the value of side AC. Now this is an interesting question. Many questions are formed on this concept where a perpendicular is drawn on the hypotenuse from the right angled triangle in a right angled triangle. So if we analyze these triangles, so angle A is 90 degrees. So in triangle ABC, angle A is 90 degrees. If I assume B as theta, so angle C will be 90 minus theta, because their sum of B and C should be 90. So if B is theta, so C has to be theta less than 90 degree. Now similarly in the triangle ADC, angle D is 90 degree as AD is perpendicular to BC. So sum of the other two sides, that is angle DAC plus angle C, should be 90 degree. Now C is 90 minus theta, means theta less than 90 degrees, so this should be theta. And angle A is 90, one part of that is theta, so other part should be 90 minus theta. So in this way we can see that in triangle ABC, ABD and triangle ADC, all the angles are theta, 90 minus theta and 90 degree. So we can say that all these three triangles are similar to each other. Now depending on this, we will use the information to find out the value of x, that is AC. Now first of all we have to think that x is part of triangle ADC also and triangle ABC also, and in triangle ABC, BC is known and AC is known, and in triangle ADC, DC is known and AC is known. So in these two triangles, two sides are known, means one of them has to be found out. So we will try to use the similarity. Triangle ABC is similar to triangle. Now ABC is similar to which triangle? We have to find out. So angle A is 90 degree, and in triangle ADC, D is 90 degree. So we will keep D first, and C is common in both, so C will be last, as C is last in the ABC. So in ADC only alphabet left is A. So triangle ABC is similar to triangle DAC. Now using this similarity, we can see that side opposite to angle A is BC in the larger triangle, and A is 90 degrees, so D is also 90 degrees. Side opposite to D is AC. So BC by AC will be equal to side opposite to B, that is angle B, theta, is AC in the larger triangle, and angle B is equal to this angle A, and side opposite to A is DC in the smaller triangle. So BC is 16, AC is X, and DC is 4. So from here, by cross multiplying, we can say x square is equal to 16 into 4, that is 64. So this implies that x is plus minus 8. Now plus minus 8, and AC is the length of the side. So x is length of the side, so it has to be positive, so x will be 8 centimeter. So in this way we can find out the value of AC. So let's quickly go through how we solved this question. So a triangle ABC, a right angle triangle at angle A was given, and a perpendicular AD was dropped on the hypotenuse, and we had to find out the value of x. So we saw by trying to find out the values of each of these angles, we tried to figure out the angles, assuming it's a right angle triangle, so sum of the other two angles will be 90 degrees. So we assumed angle B as theta, so C we got 90 minus theta. Similarly in the triangle ADC, C was 90 minus theta, so A will be theta, and in triangle ABD, B was theta, so A will be 90 minus theta. So we found out that all the three triangles formed are similar to each other, and depending on our requirement, we used the similarity of the triangle ABC, the largest one triangle, and triangle DAC, which is on the right hand side. So we got that BC by AC is equal to AC by DC, and we substituted the value of BC, AC and DC, and we got that the value of x will be 8. Okay, so let's move to the question number 6. So question number 6 is, in an equilateral triangle ABC, so this is an equilateral triangle, so we can make ABC here. In an equilateral triangle ABC, if AD is perpendicular to BC, so we did the construction, AD is perpendicular to BC, then AD square is equal to, then AD square. So they have asked the value of AD square in this. So ABC is an equilateral triangle and AD is perpendicular to BC. So AD is the height of the equilateral triangle. AD is height of the equilateral triangle, and we know in an equilateral triangle its height is given by root 3 by 2 times its any of root 3 by 2 times of the side of the triangle. And if we don't know, then also you don't need to worry, you can figure it out, as area of an equilateral triangle is root 3 by 4 times side square. So area of the equilateral triangle is root 3 by 4 times side square, and we can figure out its area as half into base, so base side into height. So here we can cancel out 4 by 2, so 2, and one of the side can be cancelled out, so height will be root 3 by 2 times its side. And to get the answer of this question, we have to find out AD square, means square of the height. So we knew that AD is root 3 by 2 times BC. BC is one of its sides. So AD is root 3 by 2 times BC. And why we took BC? Because we have the options are given in terms of CD, and in any equilateral triangle, perpendicular from any of the vertex bisects the opposite side. So CD will be 2 times of BC. So from here I can write root 3 by 2 times BC is 2 times CD. So from here 2 can be cancelled out. So if I square on both the sides, so AD square will be 3 CD square. Square of root 3 is 3 and square of CD is CD square. So 3 CD square. So our answer will be 3 CD square. So this was a simple question based on the concept of equilateral triangle. So an equilateral triangle ABC was given and a perpendicular was dropped from one of the vertex to the opposite side. So it was asked that what is the value of square of that perpendicular. So first of all, that perpendicular was the height of the equilateral triangle, and we know height of an equilateral triangle, that is AD, will be root 3 by 2 times its side, and we took the side BC because options were given in the form of CD and CD was part of BC. So AD is root 3 by 2 times BC. Now in an equilateral triangle, we know perpendicular bisects the altitude bisects the opposite side. So we used that concept. So we knew that BC is 2 times of CD. So from here BC root 3 by 2 times 2 times CD. So 2 got cancelled out. So AD is equal to root 3 CD. We squared on both the sides. So we got AD square is equal to 3 CD square. Now moving to the question number 7. So this is an interesting question, and quite, if we understand the question, then it is quite easy. But if we don't understand, it can look tedious. So let's read the question. If ABC is a right triangle, right angled at B, so let's try to make it. So there is a right angle triangle, right angled at angle B. So if ABC is a right triangle, right angled at B, and M and N are the midpoints of AB and BC. So M is the midpoint of AB and N is the midpoint of BC. So M and N are midpoint of AB and BC. So we have to find out AN square. So AN is this line and CM square. So CM is this line. So this thing we have to solve. So let's first of all try to find out what is AN square and CM square, and we have to keep in mind that options are in terms of AC square. So we have to convert our options in terms of AC square. So what is AN square? So if we see ABN is a right angled triangle and AN is hypotenuse of that. So we know hypotenuse square is sum of the squares of the other two sides. Similarly, CM square. So we can see in triangle CBM, CM is the hypotenuse, so CM square will be equal to BC square plus BM square. Now we have to find out AN square plus CM square. AN square plus CM square. So AN square is AB square plus BN square, and CM square is BC square plus BM square. So from here AB square plus BC square, so in triangle ABC, AC is the hypotenuse, so AB square plus BC square will be equal to AC square. Now what is left? BN square. BN square. Now BN, we can see in the triangle M and N are the midpoints of AB and BC. So BN is half of BC. So I can write BN as half of BC and BC by 2 square plus BM square. Now what is BM? BM is half of AB. So I can write AB by 2 whole square. So from here I can write AC square plus, it will be BC square by 4 plus AB square by 4. AB square plus BC square by 4. So from here we can say AC square plus AB square plus BC square. AB square plus BC square is again AC square by 4. So AC square plus AC square by 4 will be 5 by 4 AC square. Now if I multiply 4 to the other side, so I will get 4 times AN square plus CM square is equal to 5 AC square. And this is what we had to find out. 4 times AN square plus CM square is equal to 5 AC square. So option B will be our answer. So firstly, looking at this question, it can look at tedious, but if we look it in parts, it will become easier. So what was the question? Question was, if ABC is a right triangle, right angled at B, and M and N are midpoints of AB and BC respectively. So ABC is a triangle, M and N are the midpoints of AB and BC respectively. Then we had to find out the value of 4 times AN square plus CM square. So first of all, we tried to find out what was given in the question, that AN square plus CM square. So to find out AN square, what we saw in this triangle, that ABN is a right angle triangle and AN is its hypotenuse. So we used the Pythagoras theorem and we got AN square is equal to AB square plus BN square. And again we had to find out the value of CM square. So CM is again hypotenuse of triangle CBM. So CM square will be equal to BC square plus BM square. Now we tried to find out AN square plus CM square. So we added both of the right hand side. So we got AB square plus BN square plus BC square plus BM square. But looking at the options, we saw that each of the options had AC square. So we tried to convert the right hand side of this equation in terms of AC square. So first of all, AB square and BC square was there and their sum was there. So we saw that ABC is a triangle, right angle triangle, and AC is the hypotenuse. So AB square plus BC square will be equal to AC square. So we used that concept. Then BN square and BM square was there. BN square, N was the midpoint of BC, so BN will be BC, half of BC. So we used that concept. So BN is BC by 2 and BN square will be square of that. Similarly, BM is half of AB. So AB by 2 whole square. So AC square plus AB square plus BC square divided by 4, because both had the same denominator. So we added the numerator. Now again we use the concept AB square plus BC square will be AC square. So we got AC square plus AC square by 4. So that came out 5 by 4 AC square. We multiplied by 4 to the left hand side. So 4 AN square plus CM square is equal to 5 AC square. So option B will be our answer. So these were the 7 questions from the topic triangles, MCQs. Generally we get descriptive questions, long answer questions or short answer questions from this topic. You will get mostly one question from this topic in the MCQ section. If there is any doubt, you can write that in the comment section. Till then, take care and practice regularly, because remember, practice makes a student perfect.